Right, today guys, this is our second presentation on integration. Yesterday I dedicated this presentation on trying to make you understand what is the relationship between integration and differentiation. And the final, I think I showed you roughly what is to integrate. So that was the relationship given, that integration is one way direction and differentiation is opposite. So these are two sides of the same coin. That's what we agreed on. But what I'm going to do today? Today, I want to look closely at what we did yesterday and try to develop some techniques or even some analytic approach to integration, because we're not going to integrate functions looking at where they started and then looking at their derivative, then integrating. That does not happen on Earth. It happens somewhere else. Are we together? So, this is what we're going to do today. Let's start exactly from here, where we are. We start by thinking of what kind of a calculation or manipulation we can do to this expression to land exactly there. Am I making myself clear? I'm saying we should start thinking of what kind of manipulation we can do to this to come back exactly to at least this one. And then say plus C to cover up all the variants of that thing there, because there are many constants there. All together. Remember I said when you are coming from this side to that side, you cannot just say the answer is this. You should pick here the most representative answer which represents everything. So according to what I see, or I think you also see, is that here we've got n. And the only way you can achieve power n here is to take this x to the power n minus 1 and put back 1 which you had subtracted. Are we there? Okay. Then the next thing is we can see that this side we don't have a coefficient n. We don't have a coefficient n. Then we need to divide by coefficient n in order to make that coefficient to 1. But where can we get that n from? We can get that n exactly from there is n there. Let's copy this n there. But we don't need that n, because when we land there, we want to land there without n. So we can get that thing exactly from this calculation by dividing this by n minus 1 plus 1. So moving from there, manipulating that way, you will see that lands you exactly there. But that's not a good choice. Because you want a good choice which will represent this one which is got plus 0 here, and represent this one which is got plus 25, this one is got plus minus 9, this one is got 5 to the power 4, and many other things in between there. Then instead of picking that, we say the integral of that will be that. So where does this take us to? It takes us to tomorrow, or some minutes from now, if we get x to the power k, dx, look, this was given here, it was given. We're only working with the power of n given. What did we do to the power of n given here? We increased it by 1 and divided by the increased power by 1. Isn't it? So if we come here now, we're going to say, if we're to integrate this and do exactly the operation we did between those two, we will say x to the power k plus 1 divided by k plus 1, and say then plus c, and they specify here that k is not allowed to be, come again, minus 1. Because if k was minus 1, then we've got a problem there. Then, when we get here, at this point, we have got what in mathematics we call power for integration. That's the power rule for integration. Exactly what I've stated there is the power rule for integration. Okay, welcome to the world of integration with power rules. We have just observed the power rule for differentiation, and you can see power rule for integration, all what it does, it reverses power rule for differentiation. All together. So if anyone has got a special question, you must have a special question. Really, if you don't have a special question now, you are not attentive. There's an obvious question you must ask. Who has got the question? Yes, my brother. How do I find C? At this moment, I don't need to find C. That's why, because you cannot know which one was it, that's why you pick a candidate C, which is just a real number, saying any number can go there, added. But when I differentiate, I'll get that. So you don't need to determine, in this type of integral, I think I mentioned briefly yesterday that this is what we call indefinite integral. If you do indefinite integral and you don't add C there, you are actually committing some kind of soft crime. But not really soft crime, serious crime. Because you are violating maths, and the maths is not something to be violated. All together? Okay. That C there is very, very important, because if you don't leave it, it changes the whole meaning of that expression altogether. So you can't do that. So plus C, all together. Okay. Can you say plus C to yourself 10 times? Okay. I hope I've got that correct. I said, what obvious question do you have? Let me show you the obvious question which you have, which you don't realize. What will happen if k is equal to 1? It's equal to minus 1. That's the question. What if k is equal to minus 1? I normally prefer, as a presenter of this kind of type of mathematics, I normally prefer to answer this question immediately. I do this, I say this is not minus 1. A student must come up and say, what if it's not minus 1? I'm not going to spend 2 days to wait to answer that question to a student. What am I going to do? I'm going to make you aware of one thing. Let's come here. If k was minus 1, and then I've got this, I think everybody here can see that if I think in other terms, this is 1 over x dx. Then when I think about that, I then suspect something, because this is rationally the only derivatives I know which come in rational form. No, that's the wrong slide. The correct slide I'm looking for is this one. I know from this presentation that the derivatives which come in rational kind of format are those of Lie. Yes or no? How? It comes, this, as you can see here, this is f of x. In other words, these derivatives, this f of x, and there I have f of x prime. So now when I see a ratio, my suspicion is that then what should I do? I should try to find some arguments or a presentable argument to say, okay, really this will integrate to Lie. Let's come back to this. Check this. I've got here, if I suspect that this is, what do I know? First of all, I know that derivative of Lie of f of x derivative, I know that this is 1, this is prime, is 1 over the argument of ln multiplied by f of x prime, which tends to be f of x prime over f of x. Then what do I do? I can take now this and say this is what I have. You have got 1 over x. I can even say multiplied by 1 to be, let that one to be this one and that one. Then I ask myself, if I multiply that one comes here, is it true that 1, I'm asking, is it true that 1 is equal to the derivative? I'll use d as an operator d on x. Is it true that the derivative of x is equal to 1? So if you are saying that, so this, what I've got here, 1 over x is actually x, in brackets, prime, not 1, prime, over x. So what I'm doing, I'm filling in the gaps which justify that this is really a derivative of ln. So once I've fitted all the details and I see exactly like that, what stops me from saying this is a derivative of ln x plus c? So then if I go back to power rule and say this is true when k is not equal to minus 1, then somewhere at the back of my mind, somewhere, I should be saying the case of minus 1 is a ln type of an integral. That is important. If I were you, I'll be writing the note. I'll be writing a note there. Okay. Then let's go back a bit and play around with what the power rule. Then we can start afresh simply and say, so if we've got f of x as a function elevated to a power, what is f of x? A function of your choice. I don't mind whether it's trigonometric, exponential, polynomial, is elevated to a power. Sorry, I didn't want to say 2, I wanted to say n. Sorry for that. That's the power n. Now, knowing the power rule for differentiation, I would say this is that n f of x n minus 1 multiplied by f of x prime. So, but there's nobody going to give me these two things looking like that, then put an integral sign over this one for me to say the answer is that. Nobody's going to do that. But then what is this going to be? Then they say if we get then f of x under integral sign to the power n multiplied by the derivative of the argument of the power there, integration with respect to x, then according to what we've just seen here, according to what we've just seen here, we can just apply that. Because here, where's the derivative argument here? I can imagine there's a 1 there. Is x a function to the power k and multiplied by 1? Y is the derivative of x, so I put it this way. So then, coming here, I've got everything. I've got a base there which is a function to a power n, and I've got the derivative of the base. Then what stops me from saying this came as a derivative originating from that's a 1, I wanted to write a 1 there, I was almost writing an n. Then this plus 1, is that all? What is missing? Plus c, and always we are dealing such a problem, we must be careful that our n is different from -1. Are we together? Okay. So already from the discussion we just in previous slide, we have already taken this for f equals to -1 prime there, f of x dx. You notice that this is what you could write as f of x power -1 multiplied by f of x prime dx, and then we've said that this is ln of f of x plus c. All together. So now we can say from today onwards, we can actually play around with integrals of power rule form and the integrals of logarithmic form. In other words, which length at the logarithm function. That's what we can say. Are we all there? Okay. So if we are all there, then let's come to this. Examples. Guys, when I'm explaining an example, to me, it's equivalent to be doing a tutorial. So if you are going to practice these exercises or exercises of the same type, I think it's best thing to maybe to just go over example once, maybe in paper form, but if you've got the video clips, if I'm recording the video clips for you, you can look at the video clip, but as you are looking at the video clip, please filter the maths into your system. Hold a pen, write as I'm writing on the video clip. And that trains you how you write the symbols, how you write the bit by bit you are writing. The math is also filtering through your pen, through your fingers, throughout your system. Then it becomes part and parcel of you. But just watching, I'm warning you, if you watch this, just watch without writing, that is dangerous. Some people have said the time a man or a woman is closest to a comma is when he or she is looking at the TV. Because almost all your thinking gets suspended, you just go, your brain lazing around like that. That is not correct. So if you watch this thing, you are very close to a comma. You must actually maybe go to a math comma and actually never do math again. Please write. Feel the symbols, go through the thinking of the thing. That's right. So let's go. Integral x squared plus 2x brackets power 2 x plus 1 in brackets dx. I'm giving you just about 1.5 minutes to think about this. And at the moment, we know what we have. We've got only two cases. This is n is not -1, so logarithm form is out. So it is logical to think along the lines of power rule and then complete the gap. There's a gap, complete the gaps, and then integrate. Right. I think by now you should be having some ideas what we must do there. Are we having a function elevated to a power and its derivative? Are we having that? Yes? I'm saying no. Who says yes? Now, if we are not having a function under the power and its derivative, the next question we must ask is, do we have a derivative or we have got part of a derivative? Altogether, if it's given as a function and a power and a derivative immediately, consider that bonus, consider that manna from heaven. What are you to do? Just to eat and chew. That's what I understand of manna from heaven. Food which just arrived, no working, nothing, you just have to eat. But I'm telling you, nobody is going to give you manna from heaven in these problems. Now, what are you saying is part of derivative? What are we lacking? But we're not just going to plug in 2 there. Somebody saying it will be derivative if it was a 2. We're not going to plug in 2 there. Instead, I'm going to insert 1. And that 1, I write it because this then when I put my 1 in parts like that, I can see what do I make closer to the function which was given so that I can create the argument. And the other part is a number, I can take it outside the integral. Is that right? So what I'm going to do is, this is what I'm going to do. Next step, I'll write here, equals. The problem was given, I'll leave it as clean as it was because I want the marker to come and start from here. And now see my manipulation. Then I'll write integral x squared plus 2x brackets squared x plus 1 dx. It's very important to leave this thing there. That's where the marker is going to try to see how we are thinking. If you mess up that thing or just write a lot of things there, then I don't see exactly where I started, then I might stop marking there. That's not right. So what I'm going to do now, I'm going to call upon my 1 now. This one, I'll write here. 2 over 2. But I know when I'm doing differentiation, I'm differentiating, let's say 3 sine x. I'll put d there, the operator d for differentiate. This is the same thing as writing 3 outside the differential operator and the differentiate sine x. Integration, exactly the same thing. Remember, integration is the inverse operator of differentiation. So if I'm integrating a function c f of x, I can take out c outside the integral sign. That d power minus 1, it says inverse of the differential operator, which is integration. Then that I apply on f of x. So what does it mean? It means if I've got a c outside the integral sign, I can pull it into the under integral sign. There's no problem. If I've got it under integral sign, I can pull it out. That doesn't change anything. Is that am I making myself clear there? So what I'm going to do now, I'm going to do exactly this. I've got this situation. I'm going to pull in a 2, only 2, according to what I need. So I'm going to write here 1 over 2 integral x squared plus 2x power 2, 2x plus 2, that dx. When I see this step, I know the person I'm dealing with knows how to integrate. Then now when you've got this thing, now yes, you have got a situation of integral of f of x power n f of x prime dx, and we have got it there. Altogether, we know what to do. So we come here, we say equals half, because we cannot throw away this half, just equals half. Then we come here and say x squared plus 2x brackets 2 plus 1 over 2 plus 1. I'm waiting for you. Plus c. Then what follows now is simplification of all this. This is 3, this is 2, so which means here we're going to end up with a 6 in the numerator. We're going to have x squared plus 2x all power 3 plus c. Then I'm done. Questions? I'm not done, we are done. Questions? Is there something which is like... Okay guys, if all issues are clear, I think it's reasonable for me to move on. Is that right? Let's move. Now, let's see if we can get another beautiful example here. Example. Let's say we have got the integral of x sine 2x cos 2x dx. And I'm telling you, don't get lost. We are still in the context of power rule. Your task is to organize your ideas in such a way that you can end up integrating this. Actually, I'm observing now that there are actually two possibilities here, depending on how you do it. But I think the most immediate possibility is easier and clear. You can handle it. So, suggestions from you guys. What do you suggest? Sorry, there was a slip of a pen there. Sorry, this x is not supposed to be there. Sorry, this x. No. Okay, let's leave the x there. I'll make the x fit the situation. Yeah, let's take it that way. Then now the x is fine. Please read this as x sine 2 x squared cos 2 x squared. Right. I can see you are almost like turning your heads upside down. Let's think through this together. Let's think through this together. Sometimes it is good to think reverse whilst you are walking in the direction which you will call forward. Think reverse, but moving in the direction which you would call forward. This is how I think reverse. For me, when I look at this x, it looks like this x is a derivative of this argument. Then any derivative argument that will come up as 4x. Altogether. Then, if I consider sine as a function whose derivative is a cos, then I can say there I've got sine 2x squared to the power 1. So it's a power function, power which is different from minus 1. Then cosine will be this cosine here. Cosine with the same kind of argument, because if a function which differentiated, it doesn't change its argument, it will be prime. So when I have that, I've got fx for this power n multiplied by fx prime. This is on the sidelines thinking. This is the thinking process altogether. By doing this, writing this thing here, I'm trying to share with you how I think, because nobody will ever see how I think, but by doing this kind of a thing, I'm showing you roughly how my thoughts are developing, and by so doing, I'm apprenticing you to sort of, do you know what is apprenticeship? Please go to a dictionary and find out what is apprenticeship. Apprentice, I think it's written this way. Apprenticeship. To me, my belief is strongly that mathematics is not something which can be taught. It's something which you can be apprenticed in. So let's not go in that English things. English is a very complicated language. So you can actually go and try to engage with that meaning of that word on your own later. But I think here I'm just revealing my thinking so that you can also maybe try to develop some kind of same strategizing and all those things altogether. So once that is like that, I can now see what's happening there. There's a 4, then I will create that 4 again and have that 4 over 4, then start my integral as x sine 2x squared. If I want to put the power explicitly and put power 1, then put the cosine 2x squared dx. Are we there, guys? Okay, we are looking at this kind of a thing. Obviously, this you're not going to write on your answer, but when you write, as you develop your solution, you must incorporate these ideas which are being debated here. Is that right? So after that, I filter in only a 4 because that's what I need for the derivative of the argument. So I leave that 1/4 out. Actually, 1 is a beautiful number in the sense that you can write it in parts like that. So I think you can see that there are not finite number of ways you can express 1. You can express 1 in infinite number of ways, just like there are infinite rational numbers. Cosine 2x squared dx. What is left for us to do? We know that if this is under integral sign, we know how we answer. Like yesterday, I said an absurd thing, which maybe some people can consider as very, very absurd. I said this integral sign is a question mark. Is a question mark contextually according to how I want you to understand this thing. It's saying it's a question mark which says here is a derivative, here is a derivative. Of what function? Then I put a question mark there. Say, there is a derivative of what function? So what do we do? We answer the question by delivering that function which differentiates to this. All together. Am I making myself clear? Okay. Yes or no? Okay. So let's leave that on out. Every day, in our everyday life integrating, we just write the integral like that, but we must carry meaning for it. What is it looking for there? There are many other interpretations of integration, but this is one of them. Give us the integral, the function which differentiates to that. So, according to the power rule, which we have seen several times now, this will say sine 2x squared 1 plus 1 over 1 plus 1. Remember, our 1 here is our n for the power rule. So, then, plus c. What follows? Integration is ended here. What follows is simplification and write things in a more compact and more representable way. So, we write here 2 times 4, 8. Then we write at the top there, sine squared 2x squared. If you want to really to put it clearly, that's the argument, plus c. Then we are done. Okay, any questions? Let's see. You want to write down on the board? Okay. I'll pause this a bit and see what we... Let's move on to another example. I'm not going to give you a warning for this example, but here's an example. Right, let's think for a while about this. If you look at this example, it's very similar to the one we started with the power 2. Can you think around that and see what how can best represent that in a more suggestive way? Okay guys, let's quickly conclude this and see what have you thought? What do you think we must do? Sorry? Is this a ratio, isn't it? Yes. Then write it like a ratio. Alright, this is x plus 1 over x squared plus 2x dx. Then check. Function derivative. Function derivative. Is it so? Not so. Then we check how can you compensate it to be derivative, isn't it? So I think the candidate is 2 over 2. Put there 2 over 2. Then in the next step, you filter in your 2, you leave your half there. Filter in your 2, get 2x plus 1 over, plus 2, over x squared plus 2x dx. Then we see we've got function derivative, isn't it? Then, voila, we've got half ln x squared plus 2x plus c. So guys, after this, you can also look at the next example then and see what you can do with that. But otherwise, because of time, I'm going to stop. We're going to stop here and obviously commit ourselves to further practice. For now, I can say thank you for listening. Meet you in the next presentation. I hope you enjoy your practice.